Before the invention of photovoltaic cells, solar concentrators were the primary means of directly harnessing the sun's abundant and essentially inexhaustible energy. By concentrating diffuse solar radiation into a single focal point, the energy density becomes high enough that as the energy is dissipated, it can be converted into useful work. For a long time, I have wanted to build one of my own solar concentrators. However, for one to function efficiently, it must have a precise parabolic geometry. Manufacturing such a device from scratch is well outside my mathematical and engineering capabilities. But fortunately, satellite TV dishes already possess this parabolic shape, with their focal point being conveniently marked by the location of the receiver. This dish was kindly gifted to me by one of my subscribers, and today I would like to see what I can make of it. At first, I started by cleaning it up, and then I proceeded to build it a stand so it could be easily pointed towards the sun. On the back of the reflector, there is a convenient alignment mechanism, but I decided to simply loosen all of the nuts so I could rotate the dish by hand instead of endlessly adjusting it with a wrench. My first idea was to simply cover the dish with reflective aluminum tape and see how far that alone could get me. So now that the reflective tape is in place, I need to remove this antenna receiver and replace it with some kind of holder in which I'll be able to place my samples. The solution here was rather simple, and I decided to use some really thick copper wire as it was flexible enough to bend while still being rigid enough to support a significant amount of weight. At last, this is what I got, and now it was time to see if I could boil some water. Despite the water becoming significantly warmer, it was still far from boiling. Perhaps this was due to the reflectivity of the can I was using, but I concluded that the reflectivity of the reflector itself was still too low. After abandoning this project for a few months, I came back to it and purchased several hundred hexagonal mirrors to glue directly over the original layer of aluminum tape. Knowing that flat mirrors could not be perfectly aligned on a curved surface, I intentionally left small gaps between them to avoid distorting the overall pattern. Now that the dish looked like something I used to imagine, I yet again attempted to boil some water.
One eternity later.
At this point, I was certain that the mirror could concentrate enough sunlight to bring a small amount of water to a rolling boil, but once again I had no success, most likely due to the high reflectivity of the small pot that I was using. So afterwards, I decided to run a quick test to see how hot the focal point could actually get. By placing a rough piece of stainless steel into the sample holder, I immediately began to see some promising results. After realizing that the temperature could get up to 200 degrees Celsius or nearly 400 degrees Fahrenheit, I decided to build a simple flash boiler to do some testing for a potential steam generator. As a final touch, I had coated the surface in some black high-temperature silica in order to make it absorb more infrared light. Even after curing, the coating began to fume under the intense heat, and after several minutes I took my first reading, which showed that the surface had reached 276 degrees Celsius. Painting it black had clearly increased the amount of energy being absorbed. Next, I decided to pour some water into the tube, and the result was quite literally explosive. Alright, so my next idea was to take this flash boiler that I made and connect it to this copper water bottle, which I got online. I figured that I could have the cooler water go down one end, and then the hotter steam or water come up the other end, and have it be a thermal pump. I just don't quite think that's gonna work, because when water is gonna boil, at some point it's gonna boil, right? Once it gets hot enough, then it's not going to go in one direction, it's gonna go in both directions. So I don't really think that this will work as stably as I expected. So what I think I'm gonna do is just spray paint this copper bottle with some high temperature ceramic coating. And as you can see, I've taken off the layer of plastic on this bottle, and I'm hoping it's gonna stick relatively well. And then I'm just going to put this directly into the focal point of my dish, and hopefully that's going to make for a pretty decent distillation apparatus. Afterwards, I reshaped the holder to fit the copper bottle, and then I did a few more tests. As you can see, the water was clearly boiling, and next I began assembling the final version of the steam generator, or rather, a simple solar distillation apparatus. First, I added some stainless steel wool to reduce bumping and provide a clear separation between the boiling water and the steam. Then I proceeded to add a steam extraction tube. Finally, I added a small amount of Teflon tape to the lid, and I decided to carry out another test to see how effectively the steam was being generated. Alright, so we are officially making steam with the infrared light from a thermonuclear reactor that is some 150 million kilometers away. Next up, I assembled the remaining part of the distillation apparatus. Since the dish has to be repositioned about every 30 minutes to follow the sun, I decided to connect the boiler to the condenser using a high temperature silicone hose. This would allow me to turn the dish without having to disturb the rest of the setup. So now that the distillation apparatus is assembled, I'm gonna go grab some water and see if I can distill it. So in my parents' backyard, we have this creek, but It's mostly dry at this point, but there's still a little bit of water. I'm gonna grab about a liter. That should be enough for my purposes. Okay, so before I do the distillation, I'm gonna quickly test this water just to see how many parts per million there are in it. So this water seems to be rather contaminated. Definitely not suitable for drinking or any lab experiments. After about an hour into the first distillation run, the average condensation rate was about 1 to 2 drops per second, which indicated that the device was producing roughly 110 to 250 watts of thermal power. That's roughly equivalent to the power consumption of a 100 watt incandescent light bulb, or about 75 to 150 AA batteries if each battery were delivering around 1.5 watts continuously. Now, I must admit that the efficiency of the distillation itself is not particularly high, but it was good to quantify the power output. I'm currently considering to automate the setup by using 2 servo motors to align the dish with the sun using photoresistors. At that point, I could essentially leave the whole system running for an entire day, but if you have any ideas on how I could better apply these 100 to 200 watts, let me know in the comments. Although the distillate came out to be mildly contaminated, I still think that the experiment turned out to be really well. And personally, I can finally put a check mark next to a project that I've been planning for years now. Alright, well I hope you enjoyed the video, and see you next time.